3, 2, 1. I think it started.
All right. Yeah. You're the live is on. Okay.
All right, sir. So let me pull it up. Part 2, number 9, the Graduate Management Assessment Test, the GMAT, is used as an admission criterion in many Masters of Business Administration MBA programs. The scores on the GMAT in the past have a mean score of 529. BYU professor feels now that the score has improved within the last couple of years. Determine the null and the alternative. Would the null just be the score's been 529?
Yep. The mean of the score is 529.
I'm gonna write these down just because. No, 529, and then the alternative is 529 is greater than.
Or yeah.
Greater
The mean
than
is the mean is greater than.
Cool.
Yeah, that's what I got.
Easy stuff, dude.
Yeah, I think this lesson was kind of just applying. Well, it was adding on a little bit about the theory and like what the process is and all that.
So, okay, so I do have a question, and it's going to be
Yeah.
letter B with number 9.
Okay.
I'll just go ahead and read it. Suppose you gather evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. Was type 1 or type 2 error committed? So with the types, from what I understood, is it almost kind of a which one's worse type thing?
Yeah, that's how I see it.
So it almost, not opinion based, but there's really no right or wrong answer, right?
Yeah. It's there is a right and wrong answer. I think this would not be classified as a type 2. Because the difference between a type 1 and type 2, a type 1, you are stating that it's wrong when it's really true. In type 2, it's wrong and you're not even able to find out that it's wrong. So I think for example, if there's a type of food and you believe it causes like stomach issues in newborns, and what would be worse is that you at least blow the whistle and say that it is causing problems when it's really not, or that you find out, or that you're not able to find any evidence, but it is actually causing problems.
Yeah. So type 2 would be the can't find evidence, or we know it's causing problems, but no evidence.
Yeah. As you can't find enough evidence, but it's true.
So this is a type 1 then, huh?
Yeah. Type 2, you would not be able to reject it, even though you should be able to reject it.
Okay. I'm just going off. I'm gonna pull up the answer key just so we have it.
Okay. Yeah, I got the answer key as well. I was looking over it.
Okay, so letter C. If the analysis was done at A, that little Greek A stands for alternative, right?
No, it stands for alpha, and it's the significance level. So like this, if you want to prove this wrong, you have to have a p-value that's less than the significance level.
Yes. Okay. So what is the probability of committing a type 1 error?
This one's kind of confusing. I didn't really understand it because the significance level says what's the probability that somebody, like, so 1 for this one, 1 in 100 surveys are probably going to reject the null hypothesis. So there's a probability from type 1 error. So 1% to 1 in 100. So I guess that if you get that, if you're lucky enough to get that 1%, then you are a type 1 error.
The 1%.
I don't know. It's kind of confusing.
Yeah, but the answer is 1%. I think. Does that sound right?
Yeah. Yeah, it's just the same. It's the same as the significance level.
Okay, so D, letter D. If we wanted to describe the probability of making a type 2 error, would we decrease the level of significance? If we wanted to decrease the, wouldn't we have to?
Yeah, this one's I'm not really sure how they arrived at the answer.
If you wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? I don't know, dude. What is the answer?
So increase. So let's see. So a type 2 error would be not being able to reject it. And so if you wanted a better chance of rejecting it, then you need to increase the level of significance so that your p-value will fall under that.
Okay.
I don't know. Yeah, for a type 2 error, you want to be able to let's see. No, I'm still thinking about it.
No worries. We can come back to it if we want to.
Sure. Yeah, let's keep moving on.
Okay.
All right. So I can read this one. A study by the National Association of Realtors reported in 2014 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Assuming the national standard deviation is 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. He randomly selects 15 of his clients who purchased an investment property and obtains these values.
Okay. Design the study. What is the population from which the realtor obtains his data? How did he sample this population?
So how did he sample this population?
So is that just by randomly selecting 15 clients?
Yep. He just did a randomly selecting 15 of his clients, which it's just kind of biased because it's only his clients. It's not like anyone else in his community, but I don't know. How did he sample his population? He just asked their age. What is the research question? The question is are the people in his area? Let's see. Are they different in age than the national average?
Yeah. Collect the data. Name at least one way the realtor could have randomly selected his sample. Isn't that? I feel like that's kind of a vague question. Can that just be anything?
Yeah, I think that he could have took all of his client contacts and
Put him in a hat.
Yeah, put them in a hat and like randomly picked them out.
Okay.
C, describe the data, graph the data in a histogram, sketch the histogram below, or cut and paste your electronic copy in a short paragraph. Describe the data using at least 5 descriptive statistics. Oh boy.
Well, let's just kind of.
Well, for this one, we would probably use Excel,
Yeah.
and it wouldn't be too hard. You only have 15 pieces of data, and they've already done it on the answer sheet. So I guess different ways we could describe the data. We could probably say, well, it's kind of left skewed.
Yeah. Left skewed and what was that? Oh, never mind. Never mind. Left skewed. We could probably get a
Scatter.
mean. Like a
Yeah,
mean.
yeah. You get the mean, the median, the 5 different numbers. Yeah, all sorts of different stuff you could do with this data. But yeah, I already went through and I calculated the mean,
Uh-huh.
and I got 46.7. I don't know. Yeah.
All right, man. Let's go on then. Move on.
Cool, cool.
Yeah.
All right, where were we?
Oh, crap. Okay.
Check the requirements. Are we there?
Since there are only 15 pieces of data, what will you need to check? Wouldn't that be the standard deviations and stuff?
Yeah. I'm not sure exactly what textbook answer for this one is, but I'd guess that you want to check like, I don't know, the skewness, or if 15 is enough.
Yeah.
Um,
Is it enough? Do we have enough samples, I guess?
yeah, that's one thing you'd want to check.
They don't really have an answer for that on. Oh, yeah, they do. Scatter
What does
plot,
it
it looks
say?
like.
Oh yeah, yeah. So I guess they made that little scatter plot with the blue line. I guess they're checking if it's like a normal distribution or not. Does it follow a normal distribution? But it looks pretty normal. Okay. Sweet.
Save the no alternative, so the no would be 47 years, and then the alternative
Yep.
would not be.
Exactly. Yep. Is it or two-tailed?
Okay, I forgot to write notes on that part. I did it on the computer, and I was on the school computer and forgot to save, obviously.
It's all good. So
Trying to remember.
one-tailed would be if you're looking at the normability applet. One-tailed would be one-sided, and two-tailed would be like both sides. So you have a two-tailed in this case because it says anything that's not equal to 47 I want to discover. If it was one-tailed, it would be more along the lines, well, I believe that everyone is a little bit older and their age is going to be above the national mean. In that case, you'd be looking just on the right side. Does that make sense?
So that would be a. You said that was a. Um, You say it would only be a one side or a two side?
Yeah, it'd be two-tailed.
Tailed.
Yep.
Okay. A or alpha equal 0.05. I don't really get the difference on that one.
I guess it just lets you know what the the standard is. Okay, so compute the test statistic. What is the formula used?
So the formula is that it's the same formula we've been using for a while now, right?
Yep.
From what I understood.
Yeah, it's your
It's
your local mean minus the universal mean divided by standard deviation divided by the square root of your sample size.
does it look like this? That one?
Yep, that's the one.
Okay.
Perfect.
So what would be the that's my other pages.
Did you get an answer for that one?
Not yet. So the value, I'm sorry. The sample mean would be, is that 47?
No, that would be the population mean. That was the national average. And for the sample mean, we would take all those 15 numbers and average them.
So 46.73.
Uh-huh. Oh man, it's been a long week. Dude, I'm already tired.
I feel you, man. Standard deviation. What's the standard deviation? Do you know?
Standard deviation's 5.
Thank you, sir. I got -2 or -0.2091.
Yep, that's about what I got too.
Okay, cool. P-value 1. First, sketch a standard normal curve, graph your test statistic along the horizontal line, shade the appropriate under it. Shade the appropriate, I think you meant to put area under the curve. Use a normal applet to compute the area under the curve.
Yep. Do you remember how to do this one?
We are using that probability applet?
Yep. Oh,
we have the z-score, right? It's -9.
Mm-hmm.
Another 20, 30 minutes. Okay, sorry. What am I looking for?
We're looking for the probability. What's the probability that that he got the mean? So we're looking at the normability applet. Did you get an answer for that one?
I got 0.166, but I think I'm wrong. I typed in the z-score.
You could screen share if you want, and I'll see what you're doing.
So I just put in, yeah, here, let's see that.
Oh man.
Is it working?
Yeah. All right, sweet. Yeah, that's right.
Well, so I just had this.
So
But
you're looking at
the answer.
Yep, that would be the answer. That's what I got too. Sweet, man. All right, so moving along. Compare the p. That's the p-value. To the level of significance, alpha, do we reject the null hypothesis or fail to reject the null? What do you think? Oh man, it's so dark.
So the p-value showed us that there's an 83% chance that the p-value, or that, I could be off, man, that the null is right. Is that what the p-value is really stating?
So the p-value is the probability that what you observed in your study. So this guy observed 46.7, and so the probability of him getting that answer is about 80%, which is pretty high. So that's, yeah, your p-value is just like the probability of your answer and the probability of your answer actually being true compared to, or sorry, the probability of finding your answer. Kind of how extreme is it?
It's not very extreme. Is that right? Because
Yeah, no,
isn't extreme? Sorry, go ahead.
No, you're definitely right. It's not very extreme because
It's
there's
only
a
when this
high
happens.
probability.
Where is it? Right there. Right
Mhm.
when this is showing, like these corners. Okay.
Yep, that's two
So
tails.
just Roman numeral V1 or VI says the p-value is greater of significance, so that 0.86 or 836 is greater than 0.05. So we failed to reject the null hypothesis. So the standard deviation has to be, what's that?
You're right.
Well, I was just reading the answer key, but thank you.
Uh,
So the 0.05, the standard deviation has to be, in this case, is the alpha. Is that right?
yeah, it has to be below that.
Okay. Boom. Understand it now. Okay, cool, man.
Yeah, the next couple questions are just like, well, state your conclusions, take action. What would you do? You probably would guess that the national average was right. Not enough evidence to reject the null hypothesis.
Yeah. Cool, man. So we got that one. You want to go ahead and let's go ahead and take that quiz.
Let's do it. Holy crap. One question.
Okay, let's do this.
Yeah.
All right.
All right. Which hypothesis involves the equality equal sign?
There, I'm just still loading.
Oh, okay.
Hang on.
Oh, it's all good.
Okay, so now I'm ready. Which hypothesis involves or equality? Isn't that the null?
Yeah, that's what I put because yeah, the null would be already known, I guess.
P-value is the probability of obtaining the same statistic at least as extreme as the that was actually observed. Holy crap, dude! There's 21 questions to this thing.
I know. Yeah, don't worry, we'll get through them.
Remember that the p-value is the probability of obtaining the sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis did you assume to be true? Isn't that the null too?
Yeah, that's like status quo. We assume that that's going to be true as much as we know, as far as we know.
Suppose the null hypothesis is mean equals 10. Use the information to answer next three questions. Which of the following represents the alternative hypothesis of two-tailed test? Oh, crap.
So do you remember this one?
I want to say it's obviously not D, right?
No. No, that's the null.
So two-tailed is it C?
Yeah, dude.
Is it really?
Yeah. Because anything besides 10 would be either less than 10 or greater than 10. So
if it was a one-tailed, it could be either A or B, right?
yep.
Yes.
Yeah,
Killing
so
it. Ooh, it left-tailed. I remember watching this in the video, and I couldn't tell from the video when it was showing these graphs here. I don't know if you can see my screen, or if you're on Google Hands.
yeah.
I couldn't read what it was showing, but
Yeah, no, you got it. It's the left and right tailed. I'll screen my share.
so the following represents the alternative hypothesis for the left-tailed test. So will left-tailed be on the left side of the mean then? So would it be B? I could be wrong. You can correct me. It's fine.
Sorry, what was that?
No, you're good. If I'm wrong, you can tell me. Good.
I don't know. You're right. It could. I'm not exactly sure about this one, but isn't left less than? Because it's.
Oh, I guess that's true. So would it be A?
Yeah. Oh, well, that's what I think at least. I could be wrong though. And then the right would be opposite.
Yeah. So right would be
Like
would
it would be
B on that
greater
one?
than. Yeah, I think so.
All right, sounds good. Okay. Which relationship would result in failing to reject the null hypothesis?
Ah, crap. Let's see. P-value is greater. Oh, this one's okay. Yeah, this one's A.
Sure. I really don't
Yeah.
know. So.
Yeah, your p-value is your probability, so it lets you know do I have enough evidence to reject it, or if it's less than, then you do. But if your p-value is greater than, and it doesn't fall under the level, then you don't have enough.
Okay.
So that one is A.
So we're going with A on that one. You said.
Yep.
That was number 8, right?
Yep. And the last one, or the next one, sorry, is the opposite, right? So it'd be B.
Alrighty. An insurance company is reviewing the current policy rates. The rates, they believe that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use this information for the next 2 questions.
Which would be the following? Which of the following would be appropriate alternative hypothesis? I think that would be C. The average claim is greater than, because you just said they are concerned that the true mean is actually higher.
Yeah, and then I'm gonna go with A on the next one.
And it's equal to, yeah. Yeah, let's see.
Okay. An insurance company randomly selects N equals 40 claims and calculates the sample mean of 1,650. Insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Yeah, because it's a large number. I think it's over 30. So
Yeah,
would it be A or C?
I think it would be A. Yep. Definitely would. I think it's A. What theorem justifies your answer to the previous question? That would be the central limit, right?
I think so. I always get those two mixed up.
Yeah, they're pretty easy to get mixed up.
I feel like it shouldn't be because like if it should be normal. It's normal when it's large, right? So
Yep.
shouldn't the law of the large numbers be?
Well,
What I mean?
the law of the large numbers doesn't address distribution, which the last question it was talking about distribution directly, and that's how I distinguish the two. Is that the central limit theorem only talks about distribution of your sample means. The law of large numbers addresses your future mean and the standard deviation of each of those means.
All right, man. So we're going with B.
Yeah, let's go with B, I think.
Which is following is the test statistic as defined in this lesson. Wouldn't it be Z?
Yeah, I think it's a Z. There's no such thing as S.
I got it right here, dude. I actually wrote that one down.
Yeah,
Boom.
nice. Sweet, dude. We're almost there.
Almost, man. Almost.
All right, the historical mean of sales receipts at a grocery store is $150. With a standard deviation of $40, the store manager suspects that the average has decreased. She sets up a hypothesis test with the hypothesis. The null hypothesis is that the mean is $150. The alternative hypothesis is that it's less than 150. Use the level of significance of 0.05, and then takes a simple random sample of 36 sales receipts from her store and computes at the mean as 144. Okay, now we're gonna need the z-score. Okay, so it'd be 144, right? Negative 150, so negative 6 divided by 36 over the square root of 36. No, the standard deviation is 40. Cool. What'd you get?
Got negative 0.9.
Yep, that's what I got too. Nice. Okay, what p-value is associated with the z-score? We're gonna need the applet for this, huh?
You just put negative 0.900. I guess just put, right?
Uh-huh. Yeah, man, I've gotten stuff wrong just because I've forgotten to round 3 decimal places.
So what'd you put? You put negative 900.
Negative 0.9 in the normal probability applet. Oh. Okay. What probability did you get for p-value?
0.368. What you're getting?
No, I got 0.184.
Your probability look like your graph?
It's right here.
Oh, you just did that left side. Okay, see, I did both sides.
Yeah. I think because we're just using the negative. Well, no, not it's because the way the way the test was set up, she's testing if it's less than, right? So
Yeah.
I don't know. I
Like
could
it.
be wrong. Cool.
So,
Uh,
interference would you make about the null hypothesis for this problem? Okay, so it's 0.184, right?
yep.
Do we compare it to 0.5 still?
0.05. Yeah.
Oh, it's wrong.
Yep. So, well, not that it's wrong. It's that we,
Right. Failed.
I guess, yeah, we failed.
Okay, what is your conclusion for this problem? We have insufficient evidence that the true population mean is 150. We have
We have
I don't know.
insufficient.
So it's either A or C, right?
I think. Yeah, I think it's C. We have insufficient evidence that the true population mean is less than 150.
That sounds right. Okay. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true? Okay, so which one involves rejecting the null hypothesis when the hypothesis? Isn't that type 1?
Yeah. Yeah, so yeah, a false assumption is better than overlooking the the defect. Is how I see it. So there's a type
Okay.
1, which is a false assumption. Type 2 would be overlooking the problem. You're not able to prove that it's a problem or it's false.
Okay. So we're going type 1 then, right?
Yeah. Sweet. 2 more.
All right. The researcher decided instead of using the level of significance of A equals 0.05, use 0.01. Which of the following will be true?
Ah, crap. Let's see. So the probability of doing a type 1 error will decrease. Probability of a type 2 error. It's definitely not A.
I honestly don't know.
So by making this happen, by decreasing alpha, we're constricting the boundary for people to reject us. Like,
Okay.
so instead of giving people a 5% chance to reject what's the status quo, we're only going to give them a 1% chance.
Okay. So is that going to be C then?
Probability that no hypothesis is true will decrease. I don't know exactly. I think it's B actually. Let's see. I have to go back to the preparation assignment. And I think it's question 9 deals with this. Question 9, part, where is that? Yeah, part D. So 9D. If you want to decrease the probability of making a type 2 error, you would have to increase the level of significance, and vice versa, right? Yeah. So I think it's B.
Okay.
Yeah, it'll be harder for people to prove that it's wrong
When
when
alpha's
when it's really wrong. I don't know. I could be wrong.
We'll find out, sir. If A equals 0.05, compute the probability of committing a type 1 error. Round to the decimal point, 2 decimal places.
Isn't that just the same as the alpha? 0.05? So 5%?
I thought it was something super easy like that.
Yeah, it is. I think, I believe it is.
All right, sir.
Awesome. Okay. Are you submitting?
Already did, sir.
Nice.
100%.
Yeah.
Nice, dude. Good work. Oh, man.
We don't have to use our retry.
That's kind of nice.
Awesome.
All
Yeah,
righty.
that's great.
Cool, man. That wasn't very long. We took care of that pretty fast.
No, that's pretty good. Not bad.
All right, man.
Sweet.
We will see you Tuesday then, huh?
Okay. Tuesday it is. Let me know if you got any more
5
questions.
o'clock.
What?
We should just always plan on 5 every Tuesday and Thursday.
We should. At 5 probably works the best.
Right. Cool, man.
Good.